So chapter 5 is about probability. So we'll first take a look at the random numbers. Random numbers. So what is randomness? So we have a class of 25 students. So if we want to select one student randomly, so what's the best way to do it? I mean, if I write down like from 1 to 25, right? 1 to 25. And also I give each student a number, right? From 1 to 25. Then put the paper into a bag, yeah? You shake it, then select one. So if that's the case, each student has what?
1 out of 25.
What is the probability of being selected? 1 out of 25, right? 1 out of 25. And how about if I want to select one more student? So altogether, I need to select 2 students.
So 2 of 25?
So when well, it depends on what?
Are you counting them together or one after the other? Then it'd be
Exactly.
24.
So remember, I have 25 numbers in the bag. So if select one, if I take a look at, it's 24, right? So 24, let's say that's John, for example. Then if I put the number outside, then when I do the second drawing,
23.
now it's one of what? 24. 24. So the second student is 24, not 25.
6 2's out, would it be 23?
Yes.
So if you take 2 out, it should be 23. Because if you
If
took
he's
1...
choosing a third, maybe.
Yeah, if I choose
Oh,
it.
so okay.
I only
One's
select
like
2
0.
students. Yeah. But here you
Yeah.
can see there's a difference. So if once I select the first student, so the first student has the chance of 1 out of 25. Second student actually depends. Depends on what? Depends on whether this is sampling with. It's called a sampling. It's not in the book here. Sampling with replacement. And the second one is sampling without replacement. Sampling without replacement. Now, in our example, if I draw, need to select 2 students. So I have 5 numbers in the bag, yeah? So I have to draw one, that's 24. So sampling with, so the first student has a chance of 1 out of 25, right? With replacement is what?
Could be back to 125.
It's still, I put the number back. So it's possible that if you're lucky, you will be selected twice, right? That's a possibility. But again, the second students, in this case, there's always 25 numbers in the bag with replacement. So the second student is also 1. But sampling without replacement, the first one, I have 1 of 25. Yeah. Second one, then is what? I take 1 of 25. Yeah, exactly. Good. So the textbook has those random numbers. So basically, if we toss a quarter, and then if we use the random number 30, yeah? The row 30. So if it's odd number, it's I believe it's head, and even number it's tail. Even number is tail. So if you follow here, this is head, what? Tail, head, tail, head, 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 yeah? Right? If it's odd number, it's head. Even number is tail. But in this case, you can see the longest strike is what? 4 heads, yeah, 4 heads. Actually, if you got nothing to do, right, you can do a test at home, right? You can try 1,000,000 times tonight, right? Toss a quarter, see, and then write down, each time you write down, yeah, write down. And so how to estimate the probability of an event? There are 2 different approaches. Oh, did I tape it? Yeah. The first approach is it's called theoretical. So if you toss a quarter, what is the probability of getting a head?
50.
How do you know?
Because there's 2 pieces.
There are 2 possible outcomes, right? One out of 2, right? 1 out of 2. So that's called theoretical approach. Theoretical approach. The second one is what? Empirical. What is empirical? You can try many times. You can try 1,000,000 times to see. I believe the number will be very close to 50%. The number will be very close to 50%. You can try many times. And actually, we can use for the random number. We can use Excel to generate random numbers. So if we use the Excel. You can type equal to rand between what, 1, for example, to 1,000. So it will produce what, a random number between 1 and 1,000. So this is 551, right? It's a random number. So probably I can save it, right? Save this file. I save this file on the desktop. So let's say a Facebook survey, okay? I save it and I close it. So may I open it again? Yes. Hold on. So I can open this file. Oh, that's fine. Yeah, so again, for the homework, you have 5 trials. Well, so if that's the case, you always get 100%. No?
No, you only have, oh, you moved it to 5?
Yeah.
Oh my God.
That's too many, yeah.
No, that's fine. Wonderful. Thank you very much.
Even for the quiz, that should be 5, right?
What a blessing.
Then everybody get a A's.
What a blessing.
That's a break. I know. Okay, I know. Okay, let's open the file, yeah? Pay attention what happened. The number is different. Why? It's a random number. It's a random number. So if you really want to keep that number, you have to what? You have to copy and paste. Oh, sorry, you have to copy, yeah? Oh, see, when we copy this number changes again. Sorry. It's a random number, so. It's a random number, so. Okay. But anyway, this is how we generate a random number. Easy. Okay. That's the whole idea. Alright. Good. So now let's take a look at find the probabilities. And I believe for chapter 5, all the questions are from, I believe, 5.2 and 5.3. All the quiz questions and also homework questions.
Straight from the book, huh?
No, I have my own questions here. Okay, so this one is the probability is always between 0 and 1. Cannot be a negative number. Cannot be greater than 1. So that's 2 points in the homework or quiz. So you have to see a bunch of numbers and ask you which numbers are probabilities, are not probabilities. Then if you see a negative number, of course not, right? And also, if you see a fraction, but if the top is greater than the bottom, so let's say 33 divided by 31, is this a probability? No, it cannot be more than 1, that's all. So 2 easy points, right, for the quiz, okay, a homework. Okay, but if it's 0, then that's called an impossible event. It's not going to happen. It's equal to 1. It's called for sure the event is going to happen. But more likely though, we have probabilities in between 0 and 1, between the impossible events and also the events with certainty, certain events. So usually we write in this way, the probability, P is probability, parenthesis, A. A is the event, can be any event, right? A head, a tail, or you pass this class, you fail this class, right? So if I tell you the probability of passing this class, so the probability of passing this class, let's say I will use A, and A is you pass this class, is 70%. So what is the probability that you will fail in this class?
30.
How do you know?
Because there's 7 out of 10, so the remainder would be 3.
And so in statistics, the 2 events are called complement events. Complement events. So the probability of the complement, so that's the notation, yeah? That's the notation, is equal to 1 minus, it's always 1 minus the probability of A, which is 1 minus 70%. So you know that's 30%. That's 30%. Is this clear? So, do you have any good examples of complement events? Pass, fail, right? Happy, not happy? Rich, poor?
Not in between.
Right? And how about, what is the probability of at least 1? At least one. So let's say you are going to have 3 children. You plan to have 3 children. So what's the probability of have at least one boy? At least one boy.
It depends.
No.
Depends on how often boys are.
Oh, I mean, let's say 50-50.
It is 50-50. It's not that way.
So the probability at least one. What is the complement event?
One.
All girls, yeah? No boys. Yes?
That's what happens. Yep.
No boys, yeah? Okay, so what's the complement event? No boys.
It's the military hazard.
So that's, so to figure out, sometimes it's difficult to figure out the probability of at least one boy because of different combination. You can have 2 boys, then 2 boys, maybe the first one's boy, the third one's a boy, right? Or you can have all 3 boys. It's more complicated to calculate. But we can do what? We can, at least one boy, we can, subtract what? The probability of what? No boys. No boys. Then no boys is what? The first one is a girl. What's the probability? We're assuming 50%. So the first one is a girl. Second one is a girl. Third one is a girl. Then that's 1 minus 1 is, that's 7 divided by 8. That's a probability. That's a probability. So the idea is the probability of at least 1 is sometimes it's equal to the probability of what? None. Is that clear? That would be a shortcut. Okay. And the sample space. Sample space is a collection of all the possible outcomes. All the possible outcomes. And the event is a collection of some outcomes. So let me give you some examples. Okay. So if you roll a die, what is the sample space? What are possible outcomes? Either 1 or 2 or 3, 6 outcomes, yeah? So this is the sample space. Okay. And event, even number, how many of them? 2, 0? No, there's no 0, right? It's what? It's from 1, right? 1, 2, 6. So 2, 4, 6. Less than 2, less than 3. 2, right? 1 or 2. Okay. So that's the difference between. Now, let's take a look at some other examples. Hold on. Look at other example. How about if you two quarters, the 2 coins, yeah? What's the sample space? Two coins, yeah? One at a time. What are possible outcomes?
Two heads.
The first one is head, second one is a tail,
Heads, tails,
and
Heads, heads.
head, tail,
let's see.
Tail, heads.
tail, head. Yeah, tail. You see how many possible outcomes? 4. So what's the sample space? 4. That's the sample space, right? So, and also let's take a look at the event. The event is you get the event, let's say you get a 1 head. So what are the outcomes? 1 head.
4.
No, 1 head. HT, yes. 1 head, yeah? How about this one, no? How about this one, no? Yes? Good. How about at least 1 head? At least 1 head.
3.
3, yeah? HT, HH, and PH. Good. And what's the event of no head?
1.
Okay? Is this clear? That's the sample space? So sample space is a collection of what? All the possible outcomes. And events are a collection of certain outcomes. So, and how about one more example? How about if we toss 2 dice? What are the possible, what's sample space? Well, each die, you have what, 6 sides, yeah, 6 numbers, yeah?
So it'd be 12, huh?
No. How to count? How to count?
36.
So how do you know 36? Well, you can say if the first one is 1, yeah? Second one is 1. First one is 1, second one is 2. Yes? First one is 1, second one is 3. First one is 1, second one is 4. First one is 1, second one is 5, and first one is 6. Then we can start what? 2, 1, yes, second one, the first one 2. So basically the sample space is 6 times 6 is 36. Because for the first die, the 6 possible outcomes. Second die, 6 outcomes. So the total is 36. And so let's take a look at some events. Yeah, some events. So if you toss 2 dice and so you add the numbers from both dice together. So what's the probability of getting 7? So get a 7. What are possibilities? 1, 6, yes.
6 to 5.
1, 6, 6, 1, yes.
Okay.
2, 5.
2, 5, 5, 2.
5, 2.
3, 4, 4, 3.
3, 4, 4, 3. How many? 3, 4, 5, 6. Yep, 6. Is this clear? Okay. So now we can basically calculate the theoretical probabilities. So that's the number of outcomes in the event divided by the sample space. Divided by the sample space. So in our example, if we toss 2 dice, yeah, if we toss 2 dice, so what's the probability of getting a 7? The combined number is 7.
7 over 36.
No, it is
6 over 36.
6 over
1, 2, 3, 4, 5, 6 out of 36.
1, 6.
But make sure,
Reduce it.
yeah, it's simplify. When you use the stats lab, you need to simplify. So it is 1 out of 6. Yeah, 1 out of 6. Good. And here we have a different examples. Here. Let's see. So the sample space, if you lower die, if the sample space is 6, yeah, and get a number less than 3, there are 2 possible outcomes. Yeah, 2. So 2 out of 6 is 1 out of 3. Yeah, 1 out of 3. If a family has 2 children, find the probability of that both children are girls. So this is similar to what? the coins, yeah, head, tail, yeah, head, tail. Boy, 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 girl, girl, boy, and then both are girls. So both are girls. That's one, right? There's only one possible out of. Sample space is what? 4, right? 4 possible.
Yes.
One out of 4, which is 25%. And sometimes we're interested in the probability of A and B. The probability of A and B. The probability of A and B. So in this case, the N means what? Both events happen at the same time. So I have this example here. So if a person is randomly selected from this group, find the probability that he is the sample space is what? 1, 2, 3, 4, 5, 6 people. That's a sample space. And is wearing a hat and raising hand. So that's 2. That's 2 out of 4. That's easier. Has 2 out of 6. Okay. And sometimes we're interested in the probability of A or B. Now, how to understand the probability of A or B? It is either A or B or both. Or both, right? Or both. So in our example, if A is wearing a hat, B is raising a hand, and then the probability for A or B is what? Someone who
Wearing a hat, raising a hand.
and or raise a hand, or both, right? Or both, or both. So if in this case, how many? How about this person? No, yeah. How about this person? Yes. A head is good, yeah. How about this person? Head and
Raise.
what? Raise a head. And this one too, yeah. So that's 3. That's 3. So that's 3 out of 6. So that's the probability for A or B. Probability A or B. And actually, I want to hold on. I want to move to here first. So usually for if the 2 events are mutually exclusive, the mutually exclusive means what? Mutually exclusive, they cannot happen at the same time. Right? They cannot happen. Do you have any good example of mutually exclusive event?
Somebody walking in a door, somebody walking at the same time.
But that's true. That's true. And
Coming to class or going to a concert? You can do
for the same night, yeah?
Yeah.
For the same night. That's mutually exclusive. Either be here or we get F, yeah? Right? To be or not to be, right? To be or not to be. That's a good example of. Okay. But for some students, during summertime, it's possible they can visit 2 countries. Japan and China, for example. Is it possible? Yes. So that's not a mutually exclusive, right? Mutually exclusive. So if the events are not mutually exclusive, in other words, they can happen at the same time, then the probability of A or B is equal to the probability of A plus probability B minus the probability of A and B. So I have to subtract the probability of A and B. But if the two events are mutually exclusive, then life is easy. The probability for A or B is just equal to the probability of A plus the probability of B. So let's take a look at some examples from here. Yeah, it seems the battery is gone. Oh, it's good. Yeah. Okay, so look at this table, yeah. Happiness. Are you happy or not? Yeah. So, and also, agree with the following statement. In a marriage, the husband should work and the wife should take care of the home. So, and then we have these tables. So basically, this is, we're trying to find out whether you're happy or not. Has anything to do with your, whether you agree or not agree with the statement, right? Yes? Whether you're happy or not happy. So that's one question, whether you're happy or not. Second question is, take a look at this statement. Do you agree or not? Yeah. So I have the data here. Yeah, I have data. So how many people are happy?
155.
No.
991.
991. No. How many? How many people are not happy? 155. How many people are together in this table, in this survey? How many people? 1146. Yes. Okay. And how many of them agreed with the statement?
287.
287, right? 287. Don't know is 95, and disagree is 764. Okay. If we randomly select a person from this table, what is the probability that a person is happy? What's the denominator? Remember, the denominator is what? It's the sample space. So the sample space, you randomly select a person from this table. What's the sample space? 1146. So this is a fraction, right? The probability is a fraction. So the bottom, the denominator is 1146, right? 1146. What's the top?
991.
991, right? 991. Okay. So if you randomly select a person from this table, and how many of them disagree the statement?
764 over 11.
764 over 1146. Okay. Then let's take a look at some events. Happy and agree. You randomly select a person from this table. That person is happy and agree. The randomly select from this table. So the denominator is what?
1146.
1164 of 46. Yeah.
Agree.
And how many of them are happy and agree? So that's 242 out of 1146. Is that clear? Yeah. So I have this answer. Yeah. Okay. And how many of them are happy or agree? Happy or agree? So now we need to find out. But actually, let's do part C first. Agree or don't know. The two events are mutually exclusive. Yes. Either you agree or you don't know, right? Or disagree. But these two items cannot happen at the same time to one person, right? Either you agree or not agree, right? Either you agree or you don't know. So if you answer I don't know, then you cannot be agreed, right? So the two events are mutually exclusive. Mutually exclusive. Remember for mutually exclusive events, how to find the probability of A and B? If I go back. Yeah, just add them together. Yeah. Oh, sorry, we should move down. It's here. Yeah? Okay, so we need to find out what the probability for A or B, right? A or B. Okay, so for part C, we needed to find the probability of agree or don't agree. So what's the probability of agree? Can you tell me what's the probability of agree? Random select from this table. Agree is what? 287 divided by 1146. And what's the probability if you select a person, random select person from this table, that person don't know, the answers don't know. 95, right? 95. Yes? 95. Yes, 95. So, in this case, the probability of agree or don't know is what? The probability of agree or don't know. It should be equal to what? The probability of agree plus the probability of what? Don't know. But do we need to subtract the probability of agree and don't know? We can, but the probability of what? Agree, you random select a person, that person agree and don't know is what? 0, right? Because the two events are mutually exclusive events. If the two events are mutually exclusive events, that's easy. So the probability agree plus the probability don't know. So the probability agree is what? 287 divided by 1146. And then the probability of don't know is what? 95. 1146. Okay, good. And now let's take a look at part B. Happy or agree. Happy. Now, we have two events here, right? Being happy and agree. The two events can happen at the same time for one person? Yes? You can agree and happy, right? Being happy. So if that's the case, we need it. If we do the calculation, of the probability of being happy and agree, it will be, so let's, so the probability of happy and agree, the probability of happy or agree, it's equal to what? The probability of happy plus the probability of agree minus what? The probability of what? Happy and agree, right? According to our formula. If the two events are not mutually exclusive, then what is the probability of being happy from this table? Happy is what? 991 out of what? 1146. And that person agree is what? 287 divided by 1146. You will have to subtract what?
242.
So it's people who are agree and happy. 242 minus 242. Because in this case, the two events can happen at the same time. So if you calculate agree, you include 242. You calculate, when you do the calculation for being happy, again you include 242. So that's why we needed to subtract. We needed to subtract. Is that clear? Yes. Or maybe if I draw so I have event. This is event A. Happy. And this is event B. Agree. And this is what? The common part, yeah, the common. A and B, right? Happy and agree. So see if I add A and B together, then we count the shaded area twice, right? The probability of agree or happy, we count this part, yeah? Then the probability of agree, we count this part. That's why we need to subtract. That's all. That's why we have this formula here. And again, that's why I have this formula. Right? If two events are mutually exclusive, then the probability of A or B is equal to the probability A plus the probability of B. And if they're not mutually exclusive, then we have to subtract the probability of A and B. Good? So let's take a look at so this we have two events here. Odd number and number is greater than 3. The two events are mutually exclusive. The two events are they mutually exclusive? So if you roll a die, it's possible you will have an odd number and also that number is greater than 3. Is that possible?
Yes.
That's 5, right? If the number 5, it satisfies both, so not a mutually exclusive. Not a mutually exclusive. Then if that's the case, the probability, oh. So if that's the case, we need to calculate what the probability of the odd number is what? How many?
1.
No.
Oh, wait, out of what? Oh, 6.
1.
Okay. So again, for this one, so the probability of odd number or greater than 3, yeah? Greater than 3. The two events are not mutually exclusive. Not mutually exclusive. So it should be equal to what? The probability of getting an odd number, if you roll a die, plus the probability of getting a number what? Greater than 3. Or, and minus what? The probability of odd number and what? Greater than 3. Greater than 3. So the odd number, what's the probability? What's the sample space if you roll a die? 6, right? 6 possible. So odd number, how many odd numbers? 1, 3, 5, right? So 3 out of 6. Plus the probability of you get a number which is greater than 3.
6.
Greater than 3 is what?
4, 5, 6.
4, 5, 6. So again 3, yeah? Yes? And odd number and greater than 3.
1, 5, and 6.
If you get a 5, right? So there's only one possible answer. So you have to substitute 1 on 6. Good? Okay. But how about the second one? The two events are mutually exclusive, right? Less than 3 and get a number 6. If you get a number 6, it's greater than 3. So if that's the case, for part B, to calculate the probability is, so again we have two events, right? Less than 3 and get a number 6. So the probability of less than 3 plus the probability of what? Getting a 6, yeah, getting a 6. But you don't have to subtract because the two events are mutually exclusive. They cannot happen at the same time. At the same time. Okay. And I have maybe one more, 2 more examples. If I tell you someone the probability for you to go to Japan is 80%. The probability of Japan is 0.8. Yeah, 0.8. The probability you will go to China, see, is 0.3. 0.3. And the probability you will go to both Japan and China is 1. No, hold on.
It's 7 or 2.
Changes. Okay. So now the question is, what's the probability you will go to Japan or China? How to read this? Is it Japan or China or both, right? You can go to both countries. But in this case, the two events are mutually exclusive? No. There's a possibility you can visit both countries, right? So what's the probability? How to calculate? What's the formula? So that's the probability of what? Visiting Japan plus the probability of what? Visiting China minus the probability of J and C. So basically this is about either or, yeah? So that's 0.8 plus 0.5 minus 0.1. So that's greater than 1. What a better example, yeah. Why? Probability has to be what? Less than 1, right? How can you get? So I have to change those numbers, yeah? 0.8, how about to 0.3? That's good. 0.3 is good. Then 0.3 plus 0.8 is minus 0.7, yeah? Sorry. And if the question also asking, what is the probability of neither? Neither countries. Remember the complementary event? We have either or, yeah? It's 0.7, so the other law is what? 1 minus 0.7, that's 0.3. Complementary event. Pass, fail, right? Is that clear? Okay. So let's take a break. So we're done with section, sorry, point 2.